G'day guys, welcome back to the channel and welcome back to my mess. The old workshop's looking a little bit cluttered, but anyway, we'll worry about that later. The main thing is to have fun, enjoy what you're doing, and that's exactly what I'm doing. So anyway, in this week's episode I wanted to speak about something that was mentioned in the comments section about welds and how to get welds smooth and what have you. Actually, sorry, forgive me, I can't remember who, but one of you guys asked if I could do a 5-minute tutorial on the welds and how to, smooth out welds and stuff like that. So it may not seem like a big thing, but I guess, everyone's at a different level of learning, and well, everyone has their own level of knowledge and understanding when it comes to cars, I guess. And so I guess in this episode what I'll do is I'll try to sort of give an example of how I do some of my welds and how I plenish them and what have you, and hopefully enjoy that. The other thing is I'll probably move on to the sills where I've been working recently. So you can see here, this is the driver's side sill area, and I've pretty much sort of finished that off. Well, I thought I'd finished it off until I discovered that I wasn't happy with the end of the sill. But just with step by step. So what I've done, you can see that little piece on the end that curves around. Well, that was actually taken from the rear of the Mustang chassis, if you like. When I cut the rear part of the floor pan off, that had to go as well. So I found that it actually matched quite nicely up the front here, although right where it turns, right that corner piece, for some reason it's a little bit flatter on the floor pan, and it's only flatter about 2 inches from the end, so couldn't really sort of have no rhyme or reason for that, but I tried to get it as close as I could. But anyway, that's welded in, and I think that that's finished off quite nice. Obviously there'll be a tiny bit of bodywork to that later. And yeah, so the only thing that I'm saying I wasn't so happy with was the end of the sill here. I pretty much matched it up to that surface there, which is where the guard bolts, so you can see there's 3 bolt holes that I've put in there, and that's where the guard bolts to, and I'll show you that later on when the car's upright. And that was 25mm, so I made the end of the sill 25mm to match it, and I kind of screwed up because it should have been more like 20mm, and at the moment I think it just looks a little bit too chunky. So I'm going to be sort of working out how to minimize that. So probably what I'll do is I'll have to cut it down here. So anyway, so yeah, this week I'll probably be fabricating this side, and we'll probably film that. I wanted to sort of do something a little different this time, and that's do one side and figure out how I was going to do it before I filmed it. So now I sort of got it figured out how I'm going to do it. I'll film this one, so we'll do that a bit later. In the meantime, I'm just going to do a little demonstration on welding, and say for example what I did on the chassis there when I plated the chassis. So I'll set something up, we'll do that as a demonstration, and hopefully that gives some of you an idea of what I've been doing here, and hopefully it helps somebody else in the future. So right, so upon setting the stage for what I was about to do, I realized that I was missing a few important ingredients. So I've just made a quick trip down to the hardware store and got my usual supplies. So some grinding discs, some flappy pedal sanding discs, and what else? Oh, some cheap paint brushes. I've got my 3.5mm drill bits for doing clecos, and a set of gloves. You wouldn't believe it, would you? Actually, recently, I don't know if anyone of you, how many people read the comments, but somebody sort of was suggesting that I should be wearing gloves because it's dangerous to use grinders and whatnot without gloves. And I don't disagree. You can't sort of have too much safety protection. And then immediately after I had done a video where I was wearing gloves, somebody suggested that you'd be foolish to wear gloves when using power tools. So I don't know, you can't win, can you? Anyway, something ironic happened on the weekend. I was grinding away, and I put the grinder down like this, and I just happened to just ever so slightly lift my finger when I put it down, and without having the guard on, my knuckle caught the edge of that flappy paddle and basically took the top of my knuckle off. So I wasn't wearing gloves. But what nobody said is about the safety guards. Nobody's mentioned anything about no safety guards. Look, I'm a bit slap happy with the way I do things. I've been, using grinders and welding all my life, and a lot of the time I don't have the guard. It may not suit me because the guard gets in the way, and maybe I've got it in some sort of tight place, and what have you. I'll probably find any excuse under the book to do things the wrong way. But yeah, so on that occasion I wasn't wearing gloves, and I didn't have a safety guard on, and there you go. So anyway, long story short, there's nothing wrong with using your safety gear. So there you go. All right, so with these, I've got the normal 1mm cutting disc. Well, actually I'll just grab a loose one. So this is what I use for all my cutting of metal. If it's not a gas axe or a plasma cutter, then I'll use these 1mm cutting disc by Flexite. Flexovit, not Flexite. Okay, so that's cutting, and then for grinding, the top of the welds off, I use these just fairly standard grinding discs. This one is a Flexovit, and this one is a Makita. Actually was just curious which one would be best, so I bought one of each. And then when I finish that, I'll just take the bulk of it off with those. Then what I'll use is these flappy paddle sanding discs. Now, I get these from Bunnings, and you can get either the blue ones or these red ones. I've found that these red ones are way, way, way better than the blue ones, but they are quite expensive. They're about $15 each. This is a 127mm by 40 grit, and they work perfect at smoothing out any type of steel. So yeah, anyway, so I'll set up just a piece of scrap metal, and we'll do a little bit of welding, and we'll take it from there. Okay, so I've got just a piece of RHS here, which this situation is going to be a little bit similar to what I did with the chassis rails on the coupe. So as you can see here, these chassis rails, they've been plated, and the reason these were plated, and I've had some negative sort of feedback about why I did this, or the fact that I did it, but the reason these were plated was there were basically, you've got a floor pan with its chassis rail, and then you've got the Falcon with its chassis rail. I had to merge the two together. I had to join them, and the other reason was because I'm adding an aftermarket suspension, which is a full front cross member and upper and bottom, upper and lower wishbone and coilovers and everything. It's a whole unit from United Speed Shop. Part of the engineering process was that in order to be able to pass engineering, the chassis had to be plated in the area where the suspension was being mounted, which is basically here. So it's going to be mounted over the top of the chassis rails, and it was essential to pass engineering that I had to plate the original chassis rail. So because I had to plate it here, and because I had to join the Mustang chassis rail to the Falcon chassis rail, it just made sense to put one plate through the whole thing, and that's why I did what I did. So what I'm doing today is similar, where I've got this RHS here, and if you like, this represents the original chassis, and these are my plates which are going to be going over it. So what I did to the Falcon is, originally it had seams that stuck up like this. Actually I'll show you, because there's still some showing. So say here, this is an original seam where the plates actually lapped. So the original chassis, they weren't just a piece of RHS, they were pressed steel, and the joins were lapped and then spot welded. so they were like exterior joins. So what I had to do is I had to cut that off, and then I had to weld the two together, and then I had to put the plates on top and then weld them. So what you could say this represents is the chassis after I cut the seams off and then welded the two together. So yeah, so have that there like that. And then what we do, or what I did, is I just put my plate so that it was just about 4 mil, 5 mil in from that flat surface there, looking down at it, and then go ahead and tack it. Actually, I didn't grind that back far enough, but so I've gone ahead and tacked it, basically so it won't move. And then what you want to do is you want to get it in a position which is easy for you to basically work with. So if I had it like that, it's going to be a little bit more awkward than if I sort of have it like that, slightly facing up to me. So just find something, sit there, see if that works. Or maybe not, I don't know. Maybe if I clamp. There, that should do. Okay, so I'm more sort of looking directly at the join. Okay. Yeah. So what I do when I'm welding something like that, which is reasonably heavy metal, I mean that's 3 mil and that's 3 mil. There's not really too much chance of blowing through, unless you had the amps like turned sky high. So at the moment I've got the welder set at 16. Don't ask me what that is because I have no idea. I can use a welder but I can't explain what all the numbers mean. So I've got the welder Unimig set to 16 and the wire speed set to 5, and when I start welding like on something like that, I actually go round and round and round in circles. That's with the MIG wire. So as the MIG wire's coming out, it's just sort of dancing in a pool of melted metal, just round and round and round sort of thing. And then, what else can I say? The other thing, yeah, you've got to get your settings. So if you're not sure about your welder, experiment with it and try to get it to a place that where it actually feels and it sounds right. Like you can actually hear a MIG welder when it's not really working. It's like it's spluttering and it's throwing splatter and, you know, blobs of metal everywhere and whatnot. But when you get it so it's really running right, when you get the temperature and the wire speed just right, it almost hums, like it almost sort of buzzes when you're welding. And that's something that you'll just learn through trial and error. So that's all I'd say to somebody that hasn't done a lot of MIG welding, is get scrap metal and just sit there and experiment with it. You know, you'll learn more by experimenting and, you know, trial and error and failing a few times than you will from reading a book. I assure you of that. So anyway, I'll get started on this. We'll see if we can put a run through. So this is going to be a really wide weld. Basically, I've got to start right just above that edge. I've got to bring it right down to that edge, and I've just got to build a pool of molten metal, and then I've got to stay in that pool of molten metal and just start working my way forward. Okay. So that's the weld. Now, while the weld looks fairly consistent, you'll notice that there's a hole there and a hole there. And all I could put that down to is that there must have been some impurity there, like maybe there was a pocket of rust or something like that that I didn't pick up on. But all I'd do there is during the process of smoothing it out, I'd just do what's called a pickup, which is I'd come back and I'd weld that that hole shut. So anyway, just get this camera set up. Okay, so the first step in cleaning the weld up is I'm just going to use a grinding disc. So you notice that when I was grinding it, I'm going along with the weld, side to side along the weld, rather than putting the grinding disc like that on an angle and then trying to do that. All I'm going to do is just dig holes. So what I'm trying to do is keep the weld flat and bring it all down uniformly, bring it all down together. Also, what I like to do is every now and then I like to just snip my wire off just to get a clean start. And I'm just going to go back and I'm going to do a pickup on those two pinholes. Okay. So I've taken, you know, the lumpiness off it. So now I'm just going to go to the 40 grit. So essentially, cleaning your welds up is more or less the same as painting a car. When you're working with your body filler, you know, you start with 36, 40 grit sandpaper just to, you know, to take all the high spots off it and bring it down till you get to something which is relatively flat. And then you might go to 80 grit, and then you might go to, you know, 180 or something like that. And it's the same with what I'm doing, or, you know, anyone that's plenishing welds. You take all the lumpy stuff off with your grinding disc, then you get your 40 grit disc, whether it's a flappy paddle or whether it's, you know, a disc on a small air sander, which you might see me using sometimes. Yeah, like this little air sander here. But in this case, I'm using the flappy paddle. So now that I've done 40, I'm just going to hit it with 80 grit on the air sander. So each time you go to the net, like I went from the grinding disc to the 40 took out all the big gouge marks that the grinding disc left. Now the 80 grit is going to take out, you know, the big heavy scratch marks that the 40 grit left. then if you want to be really fussy, then you can hit it with a DA. Right, so that's pretty much it. Now, as you saw, that was just sort of slapped together in a few minutes, but if that was something that I was doing and I wanted a really professional finish, I'd be gouging out a couple of areas, because there's a couple of areas of porosity. Maybe it's where those pinholes were, but there's a slight bit of porosity just there and just there. At least it sort of looks like it. And like I said, that could be from impurities in the steel, or it could be the fact that maybe I missed a couple of, you know, areas of rust that were on this when I ground it up. But in either way, it's impurities coming out in the weld. Or what it could be is that you're low on gas, but I checked my gas and it's full, so it's not the gas. Yeah, so anyway, that's how I do the welding and that's how I plenish it. I think what I might do while I'm at it is I'll just set up a little bit of sheet metal and just show you how I sort of weld the sheet metal together. Okay, so I've gone and got a couple little bits of sheet metal, and I've got these little plate clamps which basically hold the steel about 1 millimeter or so apart, and that's what I like to do when I weld sheet metal. I like to have a slight gap so that you can get the actual penetration. Like if you look at your welding rod, your wire from your MIG weld, it should basically be able to fit through the gap. I'm using 0.8, by the way. It's my belief, and could be wrong, that if the metal is like pushed hard together, in other words no gap, and then you go ahead and you weld it, what you can end up doing is having a situation where there's too much metal in one spot. You've got the metal and then you've got the weld and everything on top of it. So two things can happen. You've got too much metal in one spot, or you also end up with no penetration on the other side. So you get a bunch of metal that you have to grind off, and a situation where you've basically ground all your weld off and there's very little strength left. So that's the reasoning behind having a slight gap so that you get the penetration. So anyway, I'll do a couple of tacks and we'll see how that looks. Alright, just 4 little small tacks. What I will do is we'll see if it got penetration. So there you go. I've turned it over and you've got full penetration. The weld has gone right through. The other thing, obviously, you've got to have your temperature right. I basically by mistake, I didn't check my temperature, so I went from welding that 3mm plate to doing this. I have it still set on the 16, but it seems fine, at least for the small tack. So I'm just going to leave it there for now, and then what I'll do, I'll just fill in the gap between those tacks so that I actually have a full weld. Now, if you don't want heat distortion and everything else, then you should really, you know, sort of cool it down between tacks, or, you know, take your time with it. But if you put too much heat at any given time into a piece of thin metal like that, it will distort, and then you'll have to basically hammer and dolly it out. Now sometimes I sort of I get carried away, and sometimes I basically spot. I might do, like, you know, 5 or 6 spots in one place and then move on to another place, basically because I'm impatient. Okay, before the telephone so rudely interrupted me, we'll carry on. So yeah, it's just a matter of gradually working your way along and trying to make sure that those tacks join each other. Like, you know, pay close attention that you don't sort of, you know, skip ahead and sort of leave a bit of a gap. Right, so I've got a full weld there on that side and basically 90% penetration there. There's a couple little spots where it's missing, but I'm sure she'll hold. So what I'll do now is I'll just take these clamps off and then we'll plenish it. Okay, so that little area is now ready to be plenished, but now I did sort of like, you know, sort of rush through that just for the purpose of demonstration. So, you know, I didn't really give it time to cool down or anything. I just spotted it all together. Now you'll notice slight twist in it. It's basically the plates have, yeah, just slightly bent away from the direction of the weld. So anyway, I'll go ahead and finish it. And I'll put some gloves on. How about that? What would be even better is to clamp it to the bench. So again, I've got a couple of spots of porosity in there, and I don't know what's happening today, probably because I'm trying to film it. Yeah, I'm not winning today. So that's, yeah, that's basically it. So that's the two surfaces just basically spot welded together. Spot weld's probably the wrong term, isn't it? But yeah, so just a series of tacks basically, joining it together. It's been smoothed and plenished, and smooth as a baby's bottom on that side. And Then obviously on the back side you've got your penetration coming all the way through, and depending on the application it's up to you whether you'd want to smooth that off or just leave it as it is. I mean, the more weld you leave, the more strength it's going to have. So like I say, it depends on the application, but yeah, so that's how that works. So that's generally, like if I'm using a MIG, that's how I join sheet metal, just spot welding it together like anyone else that you might watch would be doing. And then of course you've got TIG welding, and TIG welding again is you know, it's different. I like TIG welding, to be honest. When I built my GT it was all TIG welded pretty much. Then that welder busted and I never replaced it, and then during the process of building this coupe I bought this MIG welder, which is super good. I mean, it's a really great welder, and ever since I bought that I haven't really missed the TIG. But it does have a TIG application, but it's like a touch start TIG, which is like your basic TIG. So in other words, your tungsten has to touch the metal in order for it to arc up. And I have used it a few times. I used it on the bonnet and whatnot, but just when you're sort of like, I don't know, you're building away and whatnot, the MIG it seems to be faster, and you can do some really good welds with TIG. Like you can really lay, you know, like a row of coins, you know, if you sort of put your mind to it. And so those are just two forms of welding. What else do we do? You could do your vertical. So I'll just grab a couple of bits of metal maybe and we'll look at vertical. Lean it against something that's bound to tip over. There you go. Okay. We shall endeavour to do vertical. Vertical down. MIG is really good for vertical down, super easy. So depending on the thickness, again what I do with vertical down is I'll go side to side like that. If it's thin, then I'll simply spot it, but always staying within the pool of molten metal or the metal that is still orange. So if I'm spotting, I might like do a good spot, I'll pull away and then I'll see the glow go out of it. As soon as the glow is going out of it, like the orange starts fading, then I'll spot it again right on the edge of that. And anyway, we'll see how we go. Alright, so there you go. Hopefully you get the idea. So all I was doing there was just making a heavy spot, not spotting and then pulling away. I was spotting, building up the molten metal, pulling it over to one side and back again, and then pulling off. So just like, maybe you could call it a heavy spot. I don't know. Yeah. And that's how she ends up looking. So again, there was some porosity right when I started, and I felt that it was because this maybe because this was galvanized, but as I got the heat going, it went away. But yeah, then you just do whatever you want to do, leave it like that or grind it, smooth it, whatever. So there you go, that's a little bit about welding. So I hope you've enjoyed it and got something out of it. And yeah, so that's just a little bit. Look, I'm no expert and I'm not trying to teach anybody, but somebody asked how I do it, and there you go. That's a little bit of, you know, some of the sort of style of welding that I do. And like I said, I hope you got something out of it. And don't forget, guys, grab yourselves a t-shirt, and as I said before, I'll have some caps and stickers on the way soon. So hope you enjoyed this one. I'm going to cut it off there. I'm going to leave it just about the welding for this one, and then in the next episode, hopefully, you know, this week still, I'll get onto those sill panels and get straight into some more fabrication. So catch us next time.